Just let me know. Can everyone see it?
I can see it.
Yep.
Perfect. So, real quick before we get started, who here, show of hands, has any experience working with data frames and, working within their respective languages?
So I've only seen a couple of like presentations about stuff like this, but I've never actually worked with it in like a real setting. So I'm sort of beginner when it comes to this.
Yep, I worked with it once on somebody's R code, so a
Yep.
super beginner.
Okay. Yeah, I mean, this is going to be relatively high level. It's more just more of an introduction into data frames and what they can offer for, your uh, typical engineer, or whether or not you're working in strictly databases or a data engineer or data scientist. I think there's a lot of value in data frames. And so we'll kind of explore the 6 W's of data frames, which we'll kind of touch on. So, welcome to Pandas, Koalas, and Sparks. Oh my! I would like to think that my naming convention here helped drive the name for the sequel Saturday, because I noticed that is very similar. But if not, it's also hugely coincidental. um, anyways, so starting with about me, if it goes. There you go. My name is Daniel Woods. I'm a senior consultant. I joined Talavant in 2018 around July. I worked oh, as a BI developer and BI services in healthcare. Actually worked with Jake a little bit in Epic before he transitioned off the team, or I transitioned off the team. I don't know. It was a weird time. Um, But so I worked at Epic for a little bit before joining Talvon, and um, I have a mathematics and economics background from college, and just some fun information about me. I love going to trivia. I actually saw Jake at Sugar River Pizza for trivia a couple of weeks ago, and I enjoy going to the gym because I'm a very firm believer that a healthy body and healthy mind go hand in hand. Quick question: can you see my taskbar? Is it popping up and flashing orange?
Yes.
Okay, let me see if I can maybe just share the presentation and not the screen. There we go. Share. Is that better?
Yeah, I think that's better.
Great.
Okay, cool. All right. So a little bit about Talavant, which, I mean, if we were all here last time, we kind of know, but it was established in 2015. We have offices in Milwaukee and Madison, but we have a lot of remote employees. We have some in Chicago, Minnesota, and Portland. The 25 employees, I think, is actually outdated. We're definitely increasing and continually increasing as we look to take on more of a central role in management consulting and business intelligence consulting. And the average experience of our consultants is about 10 years. We do a lot of things, mostly by helping focus leadership and get data-driven solutions and make sure that the business stakeholders are buying into the decision or the solutions that we provide, and that once we leave, that the team that we help put in place for the client is able to maintain it and understand how to keep moving it forward. One interesting piece of information that I'm not sure if anyone is actually tagged or tapped into the consulting world, but Talvon actually did just get acquired by Baker Tilly. So we are no longer Talvon come April 1st, but rather will be Baker Tilly. So this is actually like a novel presentation because it might be like the last one under the Talvon logo. And if anyone has questions about the acquisition and what that means for Talavant, I can definitely try to help answer some questions. But I think it's just pretty cool. We're looking to expand our influence nationwide, and Baker Tilly has the resources and financial power to help us accomplish that, while maintaining our team and our way of working. So I know we're all kind of excited about it. So let's dive into DataFrames. So the agenda today, we're going to talk about the 6 W's, the what, the why, the which, the how, the who, and the where. I know how technically doesn't begin with a W, but does have a W in it, so bear with me. Pun intended. So let's go ahead and start with what is a data frame. So generally speaking, a data frame is just a table-like structure. You have rows, you have columns, each column has a name. What's kind of unique about data frames is that rows can be named as well. Often you can have them reflect different observations. For example, if you're grouping on animal type and you have pandas and koalas and grizzly bears, your rows can essentially be labeled as such, being pandas with such and such observations and koalas with such and such. There's also some default null handling. So for example, Python has what we call not a number. So if your schema for your table dictates that a column is normally or supposed to be an integer, and for some reason there's a character value in there, it will replace it with a not a number value. And the data frame APIs that allow you to manipulate the data frames have built-in functions that allow you to easily remove that from the data set or massage it as needed. So it's what you would kind of hope a table structure, would have. On top of that, because we're working within, open source languages with R and Python, there's a lot of easy functions to call to read different file structures. So you can actually query directly on a SQL database to pull in the data into a data frame. And then you could write back to the SQL database. You have to set up an ODBC connection within the app or the program that you're running, but it's still relatively straightforward. So if you're familiar with SQL, you can do that. Otherwise, you can ingest CSV files, JSON, Parquet, pickles, general text files, and data frames will often try and ingest the schema and dictate what the column should be before as it's reading it. So you're not having to necessarily write out the schema hand by hand. You don't have to specify that column 1 is supposed to be an integer called ID. Column 2 is supposed to be a string. Column 3 is a date time. The data frame API is available in Python and are usually smart enough to reference that. And you can, in order to sort of improve performance, you can actually suggest it only sample part of the data to get the schema. Otherwise, you can just ingest all of the data and get the schema from there. So there's definitely a lot of flexibility when reading from files and getting your sort of data frame set up. So why would you or I want to use a data frame? Well, you kind of piggybacking on the previous point, there's easy access to all kinds of file types. You're not limited to, SQL tables, and you're not necessarily having to go through like SSIS or sort of something, any other data transformation and ingestion process. Using a data frame is just as simple as doing, pandas.read CSV and the path for the CSV file. The transformation and the manipulation in data frames is incredibly easy once you get the hang of it. Now, I will say that it's like learning a new language, you know, especially if you haven't worked in Python, if you haven't worked in R, you know, you're going to have to take baby steps just like you probably did when you first learned SQL. But in terms of being able to add brand new columns and drop new columns, change column names, like it is incredibly easy. And I feel like that's not necessarily something that is as easy in SQL, because there are certain constraints when you're working within the SQL framework that you have to kind of abide by. But with DataFrames, especially something with Python, you can define a function that takes, you know, certain column input values, runs it through, you know, we'll say like a linear regression model, and gives you a number, and then you can just append that or set a new column to that number for all points in your data frame. So then all of a sudden you have these linear regression numbers tied to each, you know, each row, that just ran through a mapping really quick. It's really nice. It is really easy. And once you kind of start working in data frames, you know, working within a sort of constrained framework like SQL becomes, I don't know, not as fun. On top of that, you know, data frames are incredibly important and useful within, you know, statistical modeling and general data science. You know, when you're looking at potentially to, when you're trying to bring in, you know, random forest decision making or different classifiers or groupings, you can't really do that with just a table, right? These functions and packages that exist in Python are take in these data frames. So if you want to sort of help bring, you know, an organization or your organization to the next level using data science, you know, data frames is really the core component of that. And then on top of that, you know, speaking about open source languages, you know, Python and R are constantly evolving. You know, it's because they are open source, they are consistently getting new additions and the ability to do new things as technology expands and people get more creative with the coding. You know, and something like Python where you can web scrape, you know, you can scrape your competitor's website, get relevant information, store that into a data frame, run a statistical comparison on like competitor prices versus your prices, and do that in a matter of, you know, minutes. And that's not something that's necessarily easily doable using some of your well-known data transformation services. So when talking about data frames, there's a lot to choose from. And by a lot, I mean there's about 3. There are data frames that exist within other languages. I believe I was doing some research. I believe F# and C# are starting to introduce data frames. I think there are a bunch of other coding languages I've never worked with that are trying to incorporate data frames into their nomenclature. But when we're talking about, you know, sort of the original data frames, we are talking about R and Python. And especially for those of us who don't necessarily have a preference between R or Python, it can be kind of difficult to choose the correct one. So I think it's important to understand when you want to choose one, like how do you choose it? So mainly speaking, in terms of general functionality for languages, R is built for statistical modeling and data analysis. It's relatively easy to pick up. I know back when I was in college, I think I spent some time learning a little bit of R, and it is relatively straightforward. You know, maybe for some of us, you know, more seasoned programmers, it may not be as intuitive because they don't actually use equal signs to set variables, but it is pretty easy to pick up. On the other spectrum of that, Python is definitely a little bit more open-ended. You know, Python has a lot of machine learning capabilities with like neural networks and general modeling for data science. And, you know, on top of that, There's a lot of application building that you can do, front end web page development using something like the Alchemy package, I believe is what it's called. But it's very open-ended, and Python is almost too big at times, so it can definitely be difficult to narrow down the scope of what you want to do and find the packages that work. But because it is so open-ended, you do have almost limitless possibilities. I think one thing that is also in favor of R is that R does come standard with a lot of the statistical analysis anyways. Python relies on a lot of package importing in order to get to the models and machine learning and everything that you need to use in order to get a functioning application. Whereas R, generally speaking, has a lot more diverse selection already built into the base programming language. So when you're trying to decide which one makes sense, it really just depends on what the end goal is, and a lot of it can also depend upon what familiarity the team has or you have with those languages. So the next sort of part is the Apache Spark ecosystem. Now, oh, sorry, my dog likes to bark at ghosts. One of the bad things about virtual presentations. So Apache Spark actually builds on top of Python and R and technically Scala, and gives us the ability to use their distributed computing ecosystem to process big data efficiently and quickly. One of the things about R and Python is that because they're not built with this sort of distributed node background, they all memory within a data frame is located on one computer, right? So if you start pulling in terabytes of data into a data frame, you could easily crash your computer if it's not equipped to handle it. Apache Spark allows you to connect to their cloud environment and actually distribute the data frame across multiple nodes, which means that you can then handle these terabytes of data a lot easier and use those use the great functionality of data frames on large data sets.
Hey, Daniel, a question.
Yeah.
Is Apache Spark, does that have something to do with Hadoop, or am I?
Yeah, yep, you're correct.
Oh.
I believe Hadoop is the underlying the underlying file system and sort of framework that Apache Spark was built on top of.
Okay.
It's complex in terms of trying to identify what Hadoop, Apache Spark, Hive, where those all kind of fit in together. But usually, I think at this point, Apache Spark is sort of the overarching umbrella that encompasses Hadoop and like Hive.
Okay, cool, thanks.
Yeah. One of the challenges with Spark is that it does have its own DataFrame API. So although you can work within the Python or R language, you kind of have to learn a whole set of other languages to use the DataFrame APIs and get access to that distributed computing power. Luckily, as some of us, they were sort of more forward thinking, they understood that it would be incredibly useful to be able to convert from a sort of Python data frame, a Pandas data frame, to a Spark data frame and vice versa. And same thing goes for R. So there is capability to switch from one to the other. One thing that is why this is sort of important is that when you're sort of working within the DataBricks environment, that strictly uses Spark in terms of its main sort of ecosystem. So you can develop locally a data frame and working application for Python, and basically pull in the Spark connectors into your local machine and still work locally for any work that you need to do. But then from there, you can then just transition into DataBricks if you need to, and utilize the functionality that DataBricks offers with the data frames that you've been working on. One other thing is, Koalas, which is, funny enough because, Pandas. Koalas is a brand new DataFrame API that's currently in beta testing and is working on rapid, iteration and, development release cycle. It is actually being developed by the DataBricks team, I believe. And what it does is that it actually leverages both the Apache Spark API and the Pandas API. What this means is that if you were to, say, leave from this virtual meeting and decide that you wanted to learn how to use Pandas and DataFrames, you could then transition into the Apache Spark environment and use Koalas to actually continue doing the same sort of work. You don't have to learn a new language in order to just work within the Spark environment anymore. Now, sort of a disclaimer, not all of the current features that are available in Pandas exist in Koalas. And from the last time I did use it, it was a little buggy and could potentially crash like a DataBricks cluster. But it is a good step forward in sort of bridging that gap between the Apache Spark DataFrame API and the Pandas API. And one of the cool things about it is that based off the size of the data in the data frame, it will actually determine how to go about certain functions or iterations on the data frame. So if you're, say, working with a couple megabyte file because you're just pulling in something, I don't know, something very small, right? And that can be handled by Pandas pretty easily. Like, you don't need to distribute it over 12 different nodes or 12 different computers. It will recognize that the data can kind of be fit onto one node and not waste unnecessary time, trying to distribute the data and then rebuild it back up when needed. But if you were then to sort of join it to a much larger terabyte file that would actually benefit from the distribution, it will do that as well. So it uses, I believe, some sampling of data sizes to understand how and what API to actually use. So it's really cool. And if you're looking to provide feedback, I know that they're, like I said, they're consistently updating it. I would like to actually start using it myself in my own projects if we can get to it, but it's kind of tricky because it is in beta. So here's some examples of how you can kind of start using data frames. I pulled some code snippets that are very simple, and we can walk through sort of what each one is doing and understand just beginning to understand how do data frames sort of start working. So the top one is the Python example, right? So we can create a data frame by just calling data frame equals pd.readcsv, and then you just type in the path name. Doing dataframe.shape gives you the width and the height of the table, so you get basically how many rows and how many columns do we have. Using dataframe.head of 1 gives you the first row in the data frame. Setting dataframe new column equal to dataframe old column plus 1 basically creates a brand new column in that data frame with the new calculated value of old column plus 1. Say your data frame actually has numerical values that you can determine the mean of. You can just call dataframe.mean, and it will give you the mean values across your whole data set. And then on top of that, if you're looking for very specific values in your data frame, you can use the .loc function to basically look for any given column value, like for example, name, where it's equal to Daniel. This is, again, sort of very high level. There's not a ton of very interesting things going on here, but it can kind of show you or give you an idea of, how easy it is to actually use DataFrames. The R example is going to be very similar. So you have, again, a read CSV to get the data frame, but you can see that it's a more of an arrow rather than an equal sign. Using the dim function gives you the same sort of is the same thing as a shape. So you get, how big is how many rows are we working with and how many columns. Again, the head function gives you the first row if you specify 1. That line 8 is actually a little bit more complicated, but basically says if the column we have is a numeric value, then give us the mean of that column and remove any sort of null values. And then we have a sampling. So basically, we get the row count by doing we grab about 80% of the rows and specify that as a row count that we want. We sample the data frame based off of the row count, and we can then just do some simple indexing to slice the data into a sampled data. This is a good way to get your statistical modeling in a place that allows you to basically have like training data versus testing data. But again, it's, the code's relatively clean, and, that's not something that's as easily done in, say, like a SQL table or SSIS, or, that, it doesn't give you quite the power to get, information like this that easily. Then we have an example of Apache Spark and DataBricks. As you can see, it's going to be, again, very similar. And that is a nice thing, is that once you have an idea of how one API works, you generally know how the other API should work, but getting the language down is most often the difficult part. So again, you can read the CSV, you can do dataframe.count and dataframe.columns and the length of that to get the shape of the data frame. You can do .show of 1. Say our data frame has a column of age, you can do .mean of age, and then do a .collect to get the mean age in your data frame. You can do .select to call out specific name and ages, and then .filter to filter those names. So very similar to what you would how you would structure, a SQL query, in that, you say select name and age where name equals Daniel, right? And then that last line shows you that we can easily convert that data frame to a Pandas data frame by just calling a .to Pandas. So there's a lot of maneuverability between the different data frames, and being able to sort of access all components of it would definitely give you an advantage in building out, great applications for any sort of data science, data exploration, or data analysis. So who would generally be interested in using data frames? In my opinion, primarily it's going to be data scientists and data engineers. The easy, manipulation of data frames for data exploration and statistical analysis just makes it a slam dunk. I think that, you can run different models. You can, look for different values. You can do, you can describe your data frames very easily. You can remove null values or highlight null values, relatively easily. You basically get all the power that you would necessarily have with trying to do some SQL interpretation of data exploration without necessarily being constrained by just the available SQL functions, right? You have a ton of capabilities in Python and R to add to the data frames to really extract out more meaningful information if you can. On top of that, R and Python both have visualization tools that make displaying the data really nice. You can start looking at like correlation between different data points and understanding how your data interacts with each other, and if there are any sort of trending data that you might not be able to see through just looking at it. But I don't think that DataFrames should be just limited to data scientists and data engineers. You know, any other sort of position that works with data, I think, can greatly benefit. Sort of, as I mentioned, table creation and alteration is easy. You can avoid using SSIS, which in my opinion is a big plus, but maybe someone here doesn't necessarily agree. But I just think that, you know, being able to use Python or R to transform your data gives you a more hands-on approach rather than, you know, trying to build out this SSIS package that, you know, basically goes from point A to point B, and you hope it, you know, you iteratively test it and, you know, execute the package, right? I think that being able to pull it into a Python notebook and see how the data is interacting and getting to those values that you need is just a huge benefit for DataFrames. And then on top of that, like I had mentioned before, Python just has a lot more flexibility when you're looking to do other things outside of just you know, data manipulation and transformation. Like you can web scrape, you can create front end web interfaces, you can create a backend SQL database in Python, which is unusual, but it can be done. But there's, you know, there's a lot of options and opportunities in Python to extend your reach for your company, and DataFrames is kind of just a natural consequence or a natural stepping stone to unlocking all that potential. So where would you really want to kind of look to use or start using DataFrames? So machine learning, statistical models, again, the way that the Python and R packages are kind of built right now is that that's really the only kind of data type that they accept. You know, you can't really put in an array of numbers into a linear regression model. I mean, I guess you could, but it's not as meaningful if you don't have multiple rows of these arrays, right? Data exploration. So again, being able to sort of prod, understand your data, get a feel for what's in it and what it means for, you know, like, I guess what your data has to offer. I think that is, you know, drawn out more so with DataFrames. And then for the third one, it's actually my personal experience as I'm working through it right now, but doing a cloud-based warehouse implementation. Now, I know that there are services out there that kind of, you know, mimic the SSIS pattern, or, you know, with Azure data flow, kind of obscure that process from the developer or the engineer. But, you know, my team at our client has, you know, been able to successfully use DataFrames to, you know, read in the data from the data lake, transform it, you know, store it as a temporary table, and aggregate the data and write it to a more persistent delta table on the data lake. And, you know, the back end of that is just, you know, DataFrames. There, you know, there is some incorporation of SQL writing into that because, you know, as I mentioned before, a lot of DataFrames do have the ability to read direct or execute SQL code directly, because when you think about it, it's all just the same, or not the same, but very similar to each other. But, you know, by using some of the capabilities provided to us in through DataFrames, we're able to kind of flesh out the process more so and use parameterization through Python to help keep our CI/CD pipeline moving, you know, flawlessly through, you know, different release cycles. And that's, you know, that's something that I think that's a lot harder to achieve if we weren't using Python and DataFrames. All right, that kind of covers, I think a very introductory overview into DataFrames and kind of how they can be thought of and what benefit they provide to sort of your general data user. And yeah, I guess let me know if you have any questions or any thoughts.
Great, thanks. Are there questions for Daniel here? I got a question, actually. So one of the things that you showed where you can sort of just, ingest almost any CSV, right? And then you immediately sort of have this data frame, which you can view more or less like I'm trying to put it in terms that I understand. So it's like, I can view it sort of like a table in SQL Server, right?
Yeah.
Could it also be a way to sort of drive a kind of ETL process? Like I could ingest everything up into some like data frame layer where I do all my, then I can do all my transformations that I've got to do with the data. I can massage it. I can null handling, whatever, and then I can blow it into a database, whatever Python does that.
Yeah, you definitely can. I mean, that is essentially what we're doing in DataBricks for our cloud data warehouse, but that it doesn't have to be strictly to a cloud data warehouse. You can read a bunch of files into your CSV. One thing I wanted to mention but forgot was that you can even join on DataFrames using, your sort of standard join conditions. You can have inner joins, left joins, full outer, etc. And then, then once you kind of get your sort of base data frames that you want to push up into a database, you just have a, pandas.toSQL, and you create database as, or create table as, or create table maybe. I don't know. I haven't actually worked with it, but I know you can definitely do it.
So anyways, I guess like the way that I was interpreting it isn't crazy. Like it sounds like a way of using this technology.
Yeah.
Awesome. Cool.
Hey,
what other questions do you got?
I follow up on that, what you said there a little bit about joining. Were you talking about joining data frames to each other?
Yep. Yeah, yep. You can join. So say you have like an employee ID column, and then you have, I don't know, something else that has employee ID in it, right? You can do a join on those columns specifically. And if say the columns don't match or they don't have the same name, you can specify what columns you're wanting to join. So it acts like you would expect a table to,
Right.
if you're writing it in SQL.
So what happens, like basically performance? Like what do you do when it's stuck? Like is there a debugging process? And
yeah. If you were to sort of work within a code editor like Visual Studio Code, it definitely has a very fleshed out debugging environment where you can kind of see how it's trying to join it and if you're actually joining it on the way that you think you do or think you are. But in terms of outside of that, it's not as if data frames themselves have debugging technology, like debugging APIs in them. It's more of just like where you're working with them in.
I think I'm seeing that. So I guess in SQL, you tell it to join something and then it compiles that and does some kind of execution plan. If you're joining stuff in a data frame, is it more deterministic, I guess?
Yeah. Well, I guess I would say, I'm not 100% sure about Pandas, but I know Apache Spark is a lazy evaluation. So the joins that you actually execute aren't executed until the data frame needs to be acted on. So you could potentially have 100 different joins and it wouldn't actually throw an error until you hit DataFrame.count, and it had to actually figure out how many things are counting. I think Pandas is a little less lazy. I think it actually executes the join, and it would tell you like column doesn't exist if you try to join on a non-existent column, but you don't exactly get a sort of execution plan, or you don't get an execution plan when working in Pandas. But if you're working with Apache Spark and working up in DataBricks, they do have execution plans, so you can actually see how your joins in DataFrames are being laid out, because it is more lazy. Yeah.
Thanks.
Yeah. Anybody else?
All right, great. Thanks, man. That was awesome. Definitely learned a lot and feel a lot more comfortable speaking intelligently about this topic. So thanks.
I mean, I'd be more than happy to do a deeper dive at some point, but I felt like, starting with.
I mean, at least for me, this was at the perfect level. So yeah, I'd be ready to go deeper another time. That'd be awesome.
Yeah,
I actually thought of another question. You mentioned Python notebooks. Are you talking about Jupyter notebook?
Yeah, you could work in Jupyter. When I talk about notebooks, usually I'm thinking about DataBricks notebooks.
Gotcha. Okay.
But they're almost the same, right? I mean, Jupyter kind of works under the same premise as a normal Python application, right? So it's a little bit easier to maybe debug there than it would be under like a standard Python file where you're running it directly against or on your system, whereas Jupyter, you could be like, in cell 1, join A and B together. If that doesn't work, it will tell you right away, right? And DataBricks is going to be very similar, but you're working again with sort of different technologies or different APIs, so you kind of have to be, I guess, cognizant of that.
Okay. Do you think it would be like a one afternoon exercise if I'm a little familiar with Python, don't really know what ODBCs are, to try to get like the data frame out of a SQL database, or is it?
Yeah, I think so. I think
okay.
I think the main thing with sort of connecting to a SQL database is that you just have to set up the ODBC connector in your Python notebook or script. But once it's there, you can just do a read _ SQL, and then I'm pretty sure you can just do like select star from whatever table you want.
Cool. I was looking at the chat. It looks like Jake had to leave.
Yeah, he has another conference call.
So I don't know if we're hostless or.
Don't worry, you guys still got me.
Okay.
Yeah, I was really just pausing for any other questions that any of the other folks may have had. Or Steve, I guess, if you have a fifth question.
I'll hold off.
I appreciate all the questions. But cool. Well, I appreciate everyone, coming and listening. I know getting used to these virtual conferences is probably going to be a little weird, but hopefully this first one wasn't too bad, and we'll keep having good ones from here on out under this pandemic.
Yes. Thanks a lot, Daniel. Thanks everyone for hopping on.